In a car race on a straight path, car A takes a time t less than car B at the finish and passes the finishing point with a speed v more than that of the car B. Both the cars start from the rest and travel with constant acceleration a1 and a2 respectively. Then v is equal to, options are given, 2a1a2 by a1 plus a2t, under root of 2a1a2t, under root of a1a2t, and a1 plus a2 by 2 multiplied by t. Is a question from 2019 JEE mains. Okay, here assume that this is the starting point. Okay, and this is the final point, finishing line. So car A is starting from the starting point and reaching finishing line. Car B is also reaching the finishing line. So this is car A and this is car B. See, given that car B is taking or A is taking t time less than car B and acceleration of car A is a1 and B is a2. We can apply kinematic equation V is equal to u plus at, and clearly given that it is starting from rest, we can say that, so the initial velocity is 0. Okay, if that is the case, we can say that the velocity Va is going to be equal to a1 multiplied by t0. Assume that t0 is the time taken by the car A to reach the finishing point. See, based on the first statement, we can say Vb is equal to a2 multiplied by t0 plus t, because it's taking some extra time, or A is taking only less time, or A is taking t time less than the B, or we can say B is equal to t time more than A. So this is the expression. So we got Va and Vb. Now see, one more condition is given. See, and with a speed v more than that of B. So Va is finishing with a velocity v more than B. That means we can write one more thing, Va minus Vb also we can write on. Va minus Vb is nothing but V given in the problem. So using this condition, we have to find out which option is matching here. See, first of all, let us find out the displacement. See how to find out the displacement. The kinematic equation again we can use S is equal to ut plus half at square. Okay, you know that very clearly from the image, from the starting point to end point, the displacement is same. So let S be the displacement. Both cars needs to cover same displacement. Fine. If that is the case, S is equal to ut plus half at square. Anyway, initial velocity is not there since it is starting from rest, so that vanishes. So we can say that car 1, for car 1 we can say half A into t0 square we can say. Fine. Similarly, S2 is equal to half A. This is A1. Okay. Half A2 into t0 plus t the whole square. Okay. See, here if you are equating these two, S1 is, you know that S1 is equal to S2. Let us equate that. S1 is equal to S2. That means 1 by 2 A1 t0 square should be equal to 1 by 2 A2 t0 plus t the whole square. See, you can see that this 1 by 2 will get cancelled out. Okay. So A1 t0 square is going to be equal to A2 t0 plus t the whole square. Okay. Now if I take a root both side, you can say that under root of A1 t0 should be equal to under root of A2 multiplied by t0 plus t. Let us open the bracket. So root of A1 t0 is equal to under root of A2 t0 plus under root of A2 t. Okay. From here we can bring t0 to other side, or I can write under root of A2 t is going to be equal to root of A1 minus root of A2 t0, because I am bringing to the other side and taking t0 common. So from here we can obtain expression for t0. What is t0? T0 is equal to, from this expression, see, root of A2 t divided by root of A1 minus A2. Root of A2 t divided by root of A1 minus root of A2. we can do one thing. We can substitute this in the initial equation. What is initial equation? You remember velocity difference equation is there, right? See, VA minus VB is equal to V. Okay, let us expand that part. VA minus VB is equal to V. We can say VA minus VB is equal to V. What is VA? A1 multiplied by T0 minus, what is VB? VB you know, A2 multiplied by T0 plus T, additional T second is taking, that is V. Okay. Now, we can open this bracket. So, V is going to be equal to A1 T0 minus A2 T0 minus of A2 T, we can say. Fine. Now, we can say A1 minus A2 we can take. See, if you are rearranging that, you will get V is equal to A1 minus A2 multiplied by T0 multiplied by A2 T. Let it be there. See, T0 we can substitute from here. From this expression we can substitute here. That means V is equal to A1 minus A2, I can always write down like root of A1 minus root of A2 multiplied by root of A1 plus root of A2, because A plus B into A minus B, A square minus B square. So, A square minus B square, here in our case A1 minus A2 will come, multiplied by T0 minus A2 T. Okay. Now, T0 we are going to substitute there. Look here very carefully. V is equal to root of A1 minus root of A2 multiplied by root of A1 plus root of A2 multiplied by T0. T0 is nothing but root of A2 T divided by under root A1 minus under root A2 minus A2 T. Here we can cancel out root of A1 minus root of A2 divided by root of A1 minus root of A2. These two things will get cancelled out. Remaining, how much will be there? Is equal to, so we can multiply this. See, A1 A2 root of A1 A2 multiplied by T. Here, see, root of A2, we can say A2 multiplied by T minus of A2 multiplied by T is there. So, we can see again these two things will get cancelled out. So, final answer, the velocity is going to be equal to root of A1 A2 multiplied by T. So, that is what we need in the problem, right? See, then V equal to, see, look here, which answer is matching? Root of A1 A2 multiplied by T. So, option 3 is the right answer in this case.